Hey everybody, I hope you're doing well. In this video we are going to look at what I guess we could call example 4. It's more of a discussion of the definition of continuity, the criteria that you have to meet in order for something to be considered continuous. And you might want to keep in mind that not everything's going to be as visually obvious. You're not always going to have a graph. You're going to have information about the derivative, the slopes, the type of function, blah, blah. And you're going to have to deduce and figure out and decide, is this thing continuous at this point? Yada, yada. So, I have color-coded 3 graphs to go with 3 types of discontinuity on our screen. First thing, sorry, I needed a sip of water. Continuous. The function is when a function is continuous, it's a single unbroken curve, and you can trace the function from left to right without lifting your pencil. So whenever you have a picture, of course, it's obvious, you could tell. Like I said, I promise in the future, if you take calc, you'll not always have a picture, you'll have information. Discontinuous this is the result if there is one or more discontinuity. Blue, removable discontinuity, more commonly referred to as a hole. The function would be continuous in the absence of the hole. So if you plug the hole, I like to think of it as spackling a hole, the function becomes continuous. Jump discontinuity, so it's in blue. We have a bit of a picture. We also have a floating point in that one. That doesn't have to always be there. Jump discontinuity. At a certain domain value, the function's value jumps and then continues. The jump creates a break in the curve where you must lift your pencil to trace it. And then third in green, infinite discontinuity. A vertical asymptote interrupts the continuity of the function. So, in order for a function to be continuous at a point, first and foremost, f of a exists. So, we're all going to pretend that a is going to be the value where our graph is having its little moment, its little discontinuity. So there's A, there's A, there's A. You get me? So that's where A is. So f of A must exist. Now, like I mentioned, oops, that eraser was too large. Hello. That point doesn't need to be there. If it's not, the blue one already fails. F of A does not exist. But if it does exist, and if it is there, okay, then it's there, and for now, blue is still in the running for continuity. Pink, same with the pink. I could have basically an open circle. Let's see, can I? There we go. I mean, it's a bit aggressive. That could happen, right? You got 2 open circles. That's very possible. But it could also be what I had drawn just a moment ago, which I think is a little bit more common, but, you know, there's no right or wrong. So in that case, okay, fine, you're still in the running as well. So it could be continuous based on the definition. We are still in the running. And then green over here, I mean, we haven't got a chance. We already failed. Fail, fail, faily, fail. All right, next, the limit. As x approaches a of f of x must exist. So the limit, okay? Let's just buckle up. As I approach the value of a from both the left side and the right side, does it look like I am approaching the same y value from both sides? Well, in this case, yes, it does, right? I'm approaching that open circle. So it does look like I'm approaching, so that open circle is my limit, whatever that y value is. So what does that mean? That means that blue could still be in the running. You're still in. As for the pink, do we look like you're approaching the same y value from both sides? Absolutely not. So you're out. All right. And even here with the green is a big discussion, okay? Yes, I'm approaching negative infinity on the left, from the left, and positive infinity from the right. However, if I even have, like, say, the volcano situation where both are pointing up and they're both approaching infinity, you would say the limit's approaching infinity. That's great. But that is still a form of does not exist. Infinity, okay? Here's my DNE umbrella. Okay? And under my DNE umbrella, right, is infinity and negative infinity. Those are forms of does not exist, okay? So if you put infinity or negative infinity as an answer, which often is the case in a volcano type of situation like that, people would probably put infinity, and people would probably put DNE for that. But what's important is that if someone asks you, does this limit exist? The answer is no. Okay, infinity is still a no. It's not a number. You're not approaching something real cute like that, okay? So green's been out, right? Anyhow. Now, still out, I guess, right? Okay. So it doesn't exist. Back to blue, and the last thing. Here's where you get the blue as being discontinuous. The f of a, the actual function value, and the limit value must be equal. They are not. Blue is out. That's what gets the blue. Pink is still out. Your function value and your limit value, I mean, not even worth it. And green, it's, you know, you're a loser. You're out. Okay? Now, remember, this definition gets more complicated, and it's really just 1, 2, 3 bullet points. Knock them out, okay? Memorize them, know them, and just get the basics. Simplify it for yourself so that you understand it. Do not overcomplicate it. If anything, you will become your own worst enemy. All right? So make sure you comprehend exactly what is going on. So, hope that was helpful. Hope you feel like you understand a little bit better. Hope you feel smarter. If you're happy and you love it, thumbs it up. Not so much, thumbs it down. Be angry. Click it hard. Hopefully, though, you're happy. Questions, comments, concerns, feedback, and requests, go in the comment section. Check the playlist. Check the description box. And that's it for now. Adios.